Hello, my awesome math students. This is Mrs. Ramsey. We are working on lesson 3.2 in this video with two learning targets. Our first learning target is to identify zero pairs, opposites, and additive inverses on a number line. We have had a head start on that learning target, so that one's going to seem a little easier to us. We are going to spend several days on adding integers. And we can learn to add integers using number lines, counters, additive inverse, and absolute value. So let's get started with our vocabulary startup. First word is opposites, and notice the pencil on the screen, so that means that you're taking notes. Integers like positive 2 and negative 2 are called opposites because they are the same distance from 0, but on opposite sides. Complete the graphic organizer about opposites. Well, we see where 0 is located on the number line, and 3 has been graphed. So let's graph negative 3. We can see on this number line that negative 3 and positive 3 are the same distance from 0. A real-world example of opposites would be cold and hot. Math example would be negative 3 and positive 3. Zero pairs. Zero pairs are opposites that always have a sum of 0. So let's look at this first example. There are 3 negative counters drawn, so we'll write negative 3, and then here are 3 positives. And if we add those together, each of these pairs add up to 0. So that means that altogether, we have a sum of 0. And it works for any pair of opposites. Here we have negative 4 plus positive 4. And since each pair of opposites is a 0 pair, negative 4 plus 4 also equals 0. Let's use what we know. 0 pairs are opposites that have the same absolute value or distance from 0. And these opposites are also called additive inverses. 2 integers that are opposites are also called additive inverses. The additive inverse property states that the sum of any number and its additive inverse is 0. We can show this on a number line. Let's take this expression, 2 plus negative 2. Starting at 0, we move in a positive direction to positive 2. We are adding negative, so we move in a negative direction 2 spaces or units, and our sum is 0. So therefore, 2 plus negative 2 equals 0. All right, time for you to try it. Prove that negative 5 and 5 are opposites using a number line and counters. Pause the video and let's check together. All right, on a number line starting at 0, we move 5 units in a positive direction to 5. We're adding negative 5, so we move back in a negative direction 5 units, and our sum is 0. You can use a negative and a positive sign instead of drawing counters. So here are 5 negatives and 5 positives. Each are a 0 pair, so all together we have a sum of 0. Adding integers with the same sign, and notice I just want you to listen. Okay, so we can use a number line that we're familiar with to solve this problem, negative 3 plus negative 2. We start at the 0, we move in a negative direction, negative 3 units, and we're adding negative 2 units. Altogether, we would have a sum of negative 5. And that's using a number line. But we can also use this rule. To add integers with the same sign, add their absolute values. The sum is positive if both integers are positive, and the sum is negative if both integers are negative. So, look here. We have the absolute value of negative 3 is 3. And the absolute value of negative 2 is 2. But wait, we are adding negatives. So that means that our answer, or sum, will also be negative. So our answer is negative 5. Now it's your turn to try. Pause the video and let's check our answers. -9, -17, and -30. What if we're adding integers with different signs? Notice, I just want you to listen. Well, we can use absolute values again. To add integers with different signs, subtract their absolute values. The sum is positive if the positive integer's absolute value is greater, negative if the negative integer's absolute value is greater. All right, let's take a look at 8 plus -5. The absolute value of 8 is 8, and then we're going to subtract. The absolute value of -5 is 5. The difference is 3. Now, which of these numbers has the greatest absolute value? 8 does. 8 is positive. Positive will be the answer if the positive integer's absolute value is greater. So our answer is correct, +3. Let's try the next problem. -12 has an absolute value of 12, and then we subtract. The absolute value of 3 is 3. The difference is 9. But wait, which of these integers has the greatest absolute value? -12 does. Look at the rule. The answer will be negative if the negative integer's absolute value is greater. So we have to add a negative sign. Our answer is -9. All right. When you are adding integers with different signs, it also might be helpful to follow this rule, which gets you to imagine a number line. It says when you add integers with different signs, start at 0. Move right for the positive integers and move left for negative integers. So the sum of p plus q is located at a distance, absolute value of q, from p. Let's use a couple examples here to see how this works. 6 plus -7. Starting at 0, we're going to move +6 units in a positive direction. Then we're going to add negative, which means that we're going to move -7 units to the left. What is the distance between the absolute value of 6 and -7? 1. Our answer is -1. Let's try this again. -15 plus 19. -15, starting from 0, in a negative direction. Then we're going to add 19 in a positive direction. The distance between the absolute value of -15 and 19, right here, is 4. We've been using counters as well to solve some problems, so I just wanted to show you something very simple like -3 plus 4. And you can draw out your counters as I have here and here. And then you can find your 0 pairs. And just kind of cross them off. Here's a 0 pair, 0 pair, here's another 0 pair. And what is left is your answer. So our answer is +1. Now that's fine when you're using really small numbers, probably 5 or less. As soon as you get to double digits, like -18 plus 25, you do not want to be using counters anymore. So instead, we can use other strategies like we've already practiced in this lesson. Now the last strategy is one that we have just started to understand in class, and that is using that additive inverse. Additive inverse also means opposite. And when you use it in an expression, it's an opposite sign change. It really is helpful when you have two signs, like a plus for addition and a negative sign right next to each other. So we have learned how we can use absolute value, we can use number lines to solve addition problems like this. Let me show you how you can do an opposite sign change. So the opposite of addition is subtraction, and the opposite of a negative is a positive. And so you have to compare this expression to this expression and decide which one is easier for you to understand. If you think that this is easier to find your answer, then you're using additive inverse. 6 and I subtract 8 equals -2. Now let's try this strategy with numbers that are larger, double-digit and 3-digit numbers. 72 plus -10. All right, opposite sign change. Instead of adding a negative, we're going to subtract a positive. All right, again, you're going to have to compare this expression, 72 take away 10, to this one, 72 plus -10. If you find that this is easier to solve, then use additive inverse. The answer is positive 62. Last problem, 120 plus -45. Let's do an opposite sign change. The opposite of addition is subtraction, and the opposite of a negative is a positive. 120, and we're going to take away 45. Again, if that looks like it's a lot easier to solve, then use additive inverse. Well, 120, and if I take away 40, I know that equals 80, and I have to take 5 more away. So my answer is positive 75. All right, finally, we can use 2 additional properties when we are adding with more than 2 addends. Commutative property states that when adding, you can change the order of addends, and addends are numbers like 2 and -15 and -2. So if we can change the order, we're going to do that to make it easier for us to find our answer. I think it would be a lot easier if I put 2 plus -2 together, because I identify those as opposites, and opposites always have the sum of 0. And then all I have to do is add -15. Well, opposites have a sum of 0 plus -15. So we have found our answer of -15. That's using the commutative property. Now, the associative property means that you can regroup. -14 and -6 are in a group because we see parentheses. I noticed something right here. -6 is an opposite of +6. So here's what we can do to use the associative property. We're going to regroup using parentheses, but this time we're going to group those opposites together using our parentheses. Our opposites give us a sum of 0, and that means that we are left with a sum of -14. -7, -4. I use the commutative property and I change the order. -17 plus -3, I know gives us a sum of -20, and -20 plus that +20. It's just easier to add if I put -17 plus -3 together. And then I regrouped using the associative property. 25 plus -25 are opposites, and that gives us a sum of 0. So our answer is -34. All right, let's end with some math humor to brighten your day. Are you sure I make a difference? I'm positive. Make it a great day.